Welcome back to part 2 of applying functions to word problems and into real life situations. Let's start. Here's another sample problem. A wire 18 feet long is to be cut into two pieces. One will be bent into the shape of an equilateral triangle whose side is of length x. Okay, x. And the other piece will be bent shaped as a circle. Okay, letter A, find a function A that represents the total area enclosed by the wire. Letter B, what is the total area enclosed if the triangle has sides of length 2 feet? Okay, so let's solve this problem. So first we need to draw. In word problems, I highly suggest drawing because it will make the process seem easier. So let's draw. What are the figures involved? So if we have an equilateral triangle. An equilateral triangle means the triangle has equal sides. So basically, we can illustrate this as, let's say this is our equilateral triangle. It'd be like this. Two lines indicate that they're equal. Two lines here, two lines here, two lines here means that they're equal in length. So that's what an equilateral triangle means. And one will also be bent into a shape of a circle. So this is our circle, let's say. Yeah. And the wire, something like this, yeah, is 18 feet long. Say this is our wire, this is 18 feet long, right? So these are the figures. So the easier way to do this is we need to get the area of the equilateral triangle and the circumference of the circle. But let's start off with the triangle, okay? Because it's the hardest one, we want to get it out of the way. Let's start with that. So in order to get the height, since we know that the area of to find the area of an equilateral triangle, that's just A is equal to BH slash 2 or BH over 2, base times height over 2. And in order to do that, we need to cut it in half to get the height. We don't know what the height is, but it says in the problem, an equilateral triangle whose side is of length x. So we can say this is x, and this entire thing is x, right? So because it says side is of length x. So x, x, x. So in order to do this, we need to use Pythagoras theorem, wherein the theorem states that c squared equals a squared plus b squared. Yes? So in order to do that, we need to get the legs. One of its legs, right? Since we can't solve the height, we can't get this one without finding its legs. So we know that if we cut this into half, this is just x over 2, since x half, and x half here, since when you add halves, that just equals to 1. And we have one of its legs, good. So in order to get the height, we just need to use this theorem, right? This is the theorem. So c squared, c will always be the hypotenuse. And a squared can be any of its two lengths. Since addition is commutative, meaning if you interchange them both together, they would still give the same sum, unlike division and subtraction. So yeah, so we can say that c squared is x squared. So since that's the hypotenuse, c will always be the hypotenuse. So x squared equals, say, let's make a x over 2 squared, since follow the theorem and we can make it as one of its legs, since it is a leg. And then we don't know what the height is. So let's just label that as h squared. and just follow the theorem, okay? We're just following the theorem. So in order to do this, we need to transpose this to the other side to get h squared. So that would be x squared minus x over 2 squared equals h squared, like that, right? So we simplify, that would be x squared minus x times 2, multiplication property of index law, x multiplied by the exponent will be x squared, and then 2 times the power of the 2 is 4 equals h squared. I'm not doing anything, okay? So in order to solve this, we know we have to get the LCD. So the LCD is 4. And we can just say this is 1, right? So 4 divided by 1, that would give you 4. Multiplied by x squared, that would give you 4x squared. 4 divided by 4, that'll give you 1. Multiplied by x squared, that will give you x squared equals h squared. And we can simplify that as 4x squared minus x squared, that's just 3x squared, since technically it's like that, over 4 equals h squared. But keep in mind, this is h squared. In order to undo something, we need to get the square root. Since we don't want h squared, we want the height. This is height multiplied by itself. To undo that, we need to find the square root. So we can write this as square root of 3x squared, square root of 4 is the same as the whole square root. So what is square root of 4? That is 2. Square root of 3x squared, that is, since there's an x squared, square root of x squared, we can put that outside. Square root of 3 in the inside, that remains, since that can't be squared. We can't get the square root of that, so put it inside. And then square root of 4 is 2. Great, we have our height. Nice, that is our first step. So now we apply the formula. How do we get the area of the equilateral triangle? We apply the formula. Base times height. Now that we have the height, then we can apply the formula. Base is this one, right? So that's the base, since that's the foundation. So technically A would equal x multiplied by the height, which is x square root of 3 over 2 divided by 2. Now, this may seem complicated, but just take a deep breath and move on. That would be x multiplied by x squared root of 3 over 2. That would be x squared root of 3 over 2. Just multiply both of the x's, that would be x squared, like this. And we know that if we encounter something like this, we need to find the reciprocal. So the reciprocal of 2, that would be 1/2, right? Since it's division, we have to find the reciprocal. So that would be x squared root of 3 times 1, still the same. 2 times 2 is 4. So that's your area for the equilateral triangle. Now, let's move on to the circle. Now that we have the area for the equilateral triangle, we need to get the area of this one. And we add both of that to get the final answer, to get the total area enclosed by the wire, since the wire is cut into 2 pieces. So we add the area of both of these to get the entire wire. So let's do that. So circumference, right? Circumference means the perimeter of the circle. So basically, logically, we can just say 18 minus the 3 x's. X plus x plus x, that's 3x. If you subtract the entire length of the wire by the perimeter of the equilateral triangle, then we can get the perimeter of the circle, right? Does that make sense? Since you just subtract this, the whole length By the perimeter of the equilateral triangle, you get the perimeter of the circle. So technically, circumference is perimeter. Well, the meaning of circumference is perimeter of the circle, right? So C equals 18 feet. What is the perimeter of the triangle? That's x plus x plus x. So it's 3x. So that would just be 18 minus 3x. C is 2 pi r, right? So we can say the formula for C is 2 pi r. So we can just say 2 pi r equals 18 minus 3x, since that's technically C, right? So we need to get the r. We know that the area, well, in order to get the area of the circle, the formula is pi r squared, or pi d, since r squared, that is just pi d, the diameter. R squared is just diameter, so pi d. So in order to get r, we have to derive the formula here. So we divide both sides by 2 pi. Just relax here, just relax. Just try to clear your head, and I'm sure it will make sense, right? So just divide both sides by 2 pi, since we need to isolate r to get the radius in order to get the area, right? So we cancel 2 pi. Then r would be 18 minus 3x over 2 pi, right? That'd be r. Okay, great. We have the radius. Now we can apply it in our formula in order to get the area of the circle. So that would just be pi multiplied by r squared, and we know that r is this, so we can technically write that as 18 minus 3x squared over 2 pi squared. Yes, makes sense. This is multiplication, by the way. Pi multiplied by r squared. I just squared this whole thing. Next, we have to simplify this. We can simplify that as 18 minus 3x squared over 4 pi squared, since 2 times 2, 4, pi squared is technically just pi squared. So technically, that's your area. So basically, we have our final area. Oh wait, we can simplify. So technically, our area of the circle would be 18 minus 3x squared over 4 pi. Yeah, and basically, so now that we have the area of the circle and the area of the equilateral triangle, we add these two now to get the area of the wire, right? Since it says it will be bent into the shape of this and the shape of the circle. So we just add that. Area, I'll write it here. Area enclosed by the wire, AEBW, would be simply this one, since it's the area of the equilateral triangle. And we add that by this one. Yeah, that's basically our final answer. Wow, thank you for sticking along with me. Wait, the box seems weird, but yeah, this is squared. Whew, we did it. After all that, finally did it. Area enclosed by the wire. We just add the area of the equilateral triangle and the area of the circle, and we did it. So that's your answer for A, since that function represents the total area enclosed by the wire. So your answer for A would be, I'll just rewrite the entire thing. Yeah. What is the total area enclosed in the triangle if the triangle has sides of length 2 feet? So basically, we can just substitute this to x, right? Since x stands for the length. So if it has 2 feet, then what would be the total area enclosed by the... Let's use a calculator, since this process is pretty tedious without one. So let's use a calculator. Wait, let me just do that. So basically means 2 squared, square root of 3. You shouldn't get a syntax error, if I'm not mistaken. And then 18, we just substitute 2. So 3 times 2, that would be 6. So negative 6. Then squared plus 4. What's pi? Pi is 3.14. I can't find it in the calculator, so I'm just writing 3.14. And we put equals. And we get 13.19. So technically, your answer would be, well, it's rounded off. So you round this off. So 13 point, technically that's 13.20. So we rounded off to 2 decimal places. C would be 13.20. A equals 13.20. Yeah, that's it.